Alright, the day is finally here for us to do some unit circle work. I would like you to take out your cardstock unit circle, and we're going to design a perfect unit circle that you'll use for the next couple of days and reference a lot. So let's make this look really nice. The first thing we're going to do is go over the angles a little bit. So the first thing we'll do is the degrees. Let's go ahead and do the degrees here, starting at 0 degrees. And maybe I'll do the 90s. 0 degrees, 90 degrees. The first little dash will be for angles. 180 degrees. Due south is 270 degrees. All right, now let's do the ones in the middle. Let's do the 5s. Between 0 and 90, halfway down the middle is 45 degrees. Between 90 and 180 is 135 degrees. Between 180 and 270 is 225 degrees. And here is 315 degrees. So, when you're looking at this, you've got the double digits, the 100s, the 200s, the 300s. Now let's go ahead and do the 30s. So we've got 30, 60, 90, 120, 150, 180. Every this much of the circle is 30 degrees. So we've got 210, 240, 270. We've got 300, 330, and if you go all the way back, 0 is also the same place as 360. All right, let's do the same thing again now with our radians, and this is where it gets a little more fun. So let's do all the quadrantals again. This is 0 radians. This is pi over 2, 1 out of 2. 2 out of 2, I'll say pi. Down here is 3 out of 2. And 4 out of 2 is 2 pi. Now let's go ahead and do the 45s, or the pi over 4s. So this is 1 out of 4. 2 out of 4. 3 out of 4. 4 out of 4. The middle here is 5 out of 4. 6 out of 4 reduces to 3 pi over 2. 7 pi out of 4. And 8 pi out of 4 we already have. Okay. After those, I like to do the ones that are really close to the x-axis. These are your pi out of 6s. So we've got pi over 6 here. And then I want to go talk over here. I know that pi is 6 out of 6. What's right before 6 out of 6? 5 out of 6. 6 out of 6. 7 out of 6. That's easy. Okay, let's go back over here to east. This is 1 out of 6. 2 pi is the same as 12 out of 6. What comes right before 12 out of 6? 11 pi over 6. Okay, and now it's just time to do the pi over 3s. The pi over 3s are easy. If you split half of the circle up into 1, 2, 3, this is 1 out of 3, 2 out of 3, and then 3 out of 3. Then we've got 4 out of 3, and 5 out of 3. And those are all the angles for the unit circle. Let's go ahead and do the points for the quadrantals, because we studied these already. So if you go due east, this point is 1, 0. If you go due north, it's 0, 1. These points over here are negative 1, 0. And due south is 0, negative 1. So that is as much as we know. And today we're going to add on the sines and cosines for all the angles in the middle. And to do that first, we need to go look in our book on page 34. So let's go over to our workbook now. And let's talk about a 45, 45, 90 triangle. So from geometry, hopefully you remember this. We've got a right angle and a hypotenuse. And a 45, 45, 90, I'm not sure how you learned this. It could have been A, or X, or even just 1, 1, radical 2. And these are your 45s. Those are exactly the same. Okay, and then the 30, 60, 90, we have to be a little more careful because the short side has to be across from the small angle, 30 degrees. So we've got a 30 degree, a 60 degree, and the rule for 30, 60, 90 was 1, radical 3, and the hypotenuse was 2. So they each had a 2, and they each have 1 radical. Okay, but we're doing some unit circle things today. So we're going to have to convert these. The hypotenuse needs to be 1. So I'm going to need to take this triangle right here, and I need to divide all 3 sides by radical 2. I need to make the hypotenuse a 1. So the hypotenuse is 1. And then, of course, I'm going to have to rationalize these 2 here, and that's going to be radical 2 over 2. Radical 2 over 2. So let's go ahead and take out our little blue triangle here, and we're going to write these numbers on our triangle. The hypotenuse is 1. One of the legs is radical 2 over 2, and the other leg is radical 2 over 2. And these angles are 45 degrees, or pi over 4s. Okay, I converted it for the unit circle triangle. Okay, I need to do the same thing now with this 30, 60, 90 triangle. I need to make it be a unit circle triangle, so I need to get this hypotenuse to equal a 1. Let's divide everybody by a 2. By a 2, by a 2. There we go. So let's go and take out our 30, 60, 90. This is going to look a little different here. So this is the short side. The short side gets 1/2 and is across from the 30 degree angle. The hypotenuse is 1, and then the long leg is radical 3 over 2, which is across from the 60 degree angle. I need you to flip this triangle over. We need to do it again on the back side. You'll see why when we're flipping it around. So copy the 90. This angle right here was 60. So let's put 60 right there. That's the 60. And this one, of course, is the 30. Across from 30, the little side was, you can take a peek or just know that it's 1/2. The hypotenuse is 1, and the other side is radical 3 over 2. You have to memorize these 3 numbers. Radical 2 over 2, radical 3 over 2, and 1/2. Okay, now let's go ahead and grab that cardstock. Get your unit circle back, and we're going to use these. So let's go ahead and focus on the blue triangle for right now. Okay, this triangle is going to help us with the 45s. This triangle should fit perfectly right into your unit circle here. Unit circle at a 45 degree angle. So here's the triangle, 45 degrees. Just kind of snug it in there if you need to. And we've got 2 values. When I say cosine, you say x. What's the x value for 45 degrees? Yeah, radical 2 over 2. And when I say sine, you look at the y value. Also, radical 2 over 2. Oh, this triangle's really easy. The sine and the cosine are both the same, radical 2 over 2s. Okay, now we're going to take this triangle, and we're going to turn it around and go put it right here into the 45 degree angle for quadrant 2. That's the same triangle. The numbers haven't changed. The only thing that's going to change here is in quadrant 2, you have to make sure that you do negative, comma, positive. Quadrant 1 was positive, positive. So what's the cosine for 135? Cosine's x, but we have to make sure that we say negative radical 2 over 2. And then the sine is positive radical 2 over 2. So all the 45 degree angles have radical 2 over 2s, you betcha. The only difference is the plus and minus sign. The 45 degree angle here is 225, and I know both of the answers are going to be radical 2 over 2, except which one gets the negative sign? The cosine or the sine? Well, yeah, both of them get negative, because in quadrant 3, remember, it's negative, negative. Okay, I'm getting the hang of this. Do you guys know what the answers are going to be for cosine and sine for 315? Radical 2 over 2's for both of them. But wait a minute, in quadrant 4, which one's going to get the negative sign? That's right, the y value. It goes positive, negative. Okay, that triangle has been exhausted. Let's go ahead and grab our other triangle here, because I notice a third angle, so with the third, it in right there. Okay, the third angle is going to be right there. And when I say cosine, you think, and the sine is the y value, 1/2. I don't know why, but I always think when I'm starting the unit circle, the very first fraction I see is the ugliest fraction of all. 1/2 is not ugly, and these are okay, 2's. Radical 3 over 2 is the first one, and he's the ugliest. Okay. 60 degrees, we're going to have to turn this triangle upside down. Good thing we got numbers back there. And get the 60-degree angle there by the origin. So we have the same fractions, except what's the cosine for 60? Now that I flipped it, I got the short side, and then the tall side goes up. So first you write 1/2, comma, radical 3 over 2. Do you see how the fractions for 30 and 60 degrees are the same? It's the same triangle, except they're switched. The cosine becomes the sine. Okay? Does anybody kind of get the idea here of how it's going to work? When I go over here to get 30 degrees, the 30-degree answers, the ratios for cosine and sine, are the same as the 30-degree ones over here. All the ones close to the x-axis. So if you'd like to start copying yourself, go ahead, but make sure you copy the right ones. Radical 3 over 2, comma 1/2 has to go by 150, the ones that are close to the x-axis, except the first fraction, negative radical 3 over 2. And then the ones that are tall, really close to the 90 degrees, the 1/2, comma radical 3 over 2 go up there. So don't flip them around and put them in the wrong place. The x and the y are still x and y. You just transfer them with a negative sign, of course, on the x. And then down here, if you put the 30-degree angle here, you could see how the x value is radical 3 over 2. So 30 degrees above 180 is the same as 30 degrees down here. It's the same triangle. You flip the triangle like that. Okay, so it's the same ratios, but they're both going to be negative. Negative radical 3 over 2, negative 1/2. The ratios for 2 pi over 3 go with 4 pi over 3. All the pi over 3 ratios are going to be the same. In quadrant 3, let's make them both negative. Here's another pi over 3. 5 pi over 3 is going to have the same ratios. 1/2, comma, radical 3 over 2, except it's the y value that gets negative. And pi over 6 is the same as pi over 6 here, except it's going to have a negative y value of 1/2. And that is how you build a unit circle. These 30, 60, 90-degree triangles that you studied so much in geometry form the unit circle. Okay, now I need you to keep this close by, just on the side of your desk, while we evaluate with it. Okay, so we built the unit circle, now it's time to use it. So 7 pi over 4. You go to your unit circle for 7 pi over 4. Okay, and I ask you, what's the sign for 7 pi over 4? Sine is the y value. The y value is negative radical 2 over 2. And that's all you do. If you know sine is y, and you know what these fractions are, you'll have your answers. Let's try again. 135 degrees. I know that's in the middle somewhere. So try to find 135, 45, 135, there it is. It's got the radical 2 over 2's, and what was I supposed to find? The cosine. Cosine is x value, and that would be negative radical 2 over 2. All right, let's keep going. 315 degrees is in quadrant 4. The sine is the y value, so that's negative radical 2 over 2. Now, in a couple of days, you're going to do this so much, you're going to have to close your eyes and imagine the unit circle. Part D, 7 pi over 6. 7 pi over 6 is here in quadrant 3, but I need to do a tangent. Tangent is sine over cosine. That's negative 1/2 over negative radical 3/2. So a couple things are going to cancel. The first thing to cancel are these over 2 over 2's. And the negatives also cancel. So we've got 1 over radical 3. Oh, we can't leave it like that. Let's go ahead and rationalize. 1 over radical 3 becomes radical 3 over 3. Okay? You could also do negative angles. All that means is you have to swing down. So instead of swinging up 30 degrees, we'll swing down 30 degrees. Here we are. And they want the cosine, so let's say radical 3 over 2. Okay? 3 pi over 4. 3 pi over 4 is up in quadrant 2. And we have to find the tangent. Tangent is sine over cosine. So we have radical 2 over 2 divided by negative radical 2 over 2. Now I want you guys to think about this. This is something, and this is the same something but negative. Same over same. That's going to be negative 1. I love tangents for pi over 4's. Sine over cosine. Sine over cosine, same over same, is going to be negative 1. Tangent for 45, same over same, is going to be a 1. 7 pi over 4, sine over cosine, same over same, that's going to be a negative 1. Tangent for pi over 4's is really nice. Tangent for pi over 3 and 6's is a little bit more work. Okay, a couple more. 2 pi over 3. Go to 2 pi over 3 in your circle and tell me the sine value. Net radical 3 over 2. Go to 135 and tell me the cosine. Negative radical 2 over 2. And the final answer is, negative 5 pi over 6. Let's see, I know where negative 6 over 6 is. Here's negative 6 over 6. 5 over 6 would be right here. But we're going to have to do some tangent work. Tangent is sine over cosine. So let's take negative 1/2 and divide by negative radical 3/2. Please clean that up for me. 2's cancel, negatives cancel, and the final answer is radical 3 over 3. Can you state the 45, 45, 90, and the 30, 60, 90 rules? Okay, can you build a unit circle with the angles for degrees, radians, and the sines and the cosines? And then can you find values using your unit circle? Okay, can't wait to see you tomorrow.